Welcome back to our learning session. Today, we'll be talking about Module 4. We'll be talking about question 3, 4, and 5. So there are three questions we'll be talking about here. Now, let's get started with question number 3, shall we? Question number 3 asks, use the same scenario from question 2. What is the expected revenue for seller? And it gives us 4 choices. And to calculate this, we're going to write a program. So let's get started. I'm going to start writing a program here. And for that, I will start by copying this to here such that it's not too cumbersome. And then I'll delete this. Once I delete this, I will start writing the program. The program should be, now let me, before I do that, let me get started with the running this information. This is important here. And I'll run this too. And now I will start working on writing a new program here. And a program should be, first of all, we have this variable called optimal route, and we have to store that somewhere so that we can reuse it later. Therefore, let's store it to a variable p, and it's going to be an optimal route. Let's run this, and it has been stored. Now, we also need to define what optimal revenue should be. And the formula of optimal revenue is this. But we had that before, right? We already have this expression before, where this is a formula for revenue. What we need to do is we need to evaluate that such that the P is equal to whatever the optimal price is, and N is this value, N equal to N, 2. How do you evaluate this? Can you tell me? We need to evaluate by starting by evaluating function, eval function. That's a function that evaluates a expression. And expression we have is f. That's the expression we are interested in. F is the expression we are interested in. And then we need to have a list. List is a function we need here, list, and p is equal to n. And once we do that, it's going to be a optimal revenue. Now let's see if it runs. And there we go. We have the value 0.3890002. That's the value we got for optimal revenue. And can you tell me what 0.38 is equal to out of this? It should be this. This is what it's equal to. Therefore, we're going to select this. This is the answer. Now, moving on to question number 4. What it says is that now we will use the R code above to test whether this prediction holds. First, let's find out the maximum valuation among all 1000 simulation among two bidders. Name the function R that allows you to get this value. The function you should use return the maximum valuation when you run the name of the function and valuations one. Please enter only function name. Now, can you tell me what is the name of this function in R? Let me show you. We'll start by taking the valuations, which is a matrix, by the way. It is a 2 by n matrix, n by 2 matrix, where R is a n and 2 is the number of columns. And then this is the valuations here. Let's run this. It's a 1000 rows here, and it has 2 columns. 1000 by 2 matrix. And for that, the answer is we need to use a max. Max should give us a maximum value out of this 2000 entries, and this will give us a 0.999306. That's a value. That's the maximum value. Now, moving to question 5, it says, take a look at the following R code that calculates the analytical solution to the expected revenue and compare it with the one coming from simulations. What variable captures the number of simulations we are using in the code? Now, let me tell you, or let me show you the R code that was given in a question. And this is the R code I am putting here for you all to see. This is the R code that was given in a question. Now, it asks what captures the number of simulations we are using code. Can you tell me by looking at this code? I can tell you that the number of simulations that captures is 1000. This is the number of simulation. 10,000. That's 10,000 is the number of simulation that was done to generate the answer. Now tell me, where is the analytical solution in this question? This is the analytical solution. This formula would provide the analytical solution for the expected revenue. And this valuations, this is a simulation being done here, and we're applying for each row, we are applying the maximum value, and then we are calculating that this is optimal price, and then we are calculating revenue using this simulated value, and then we are calculating the mean, and they should be equal to 100. Do you think it's possible? Let me show you. Let's run this and see what we get. Now we have to get 2 values here. One is from the simulation, that is 0.384, and second is 0.3849. They're really close, so we are right. Now that's all I have today. Now let's quickly review what we learned today. We learned that to evaluate, we need to use eval function, and once we use eval function, we get a value, and list is an inside list. We put all the parameters that will be gonna be used inside a function. And question 4 was about using a max function. If you have matrix, then you can use a max function to get a one single value that's a maximum value in the all the entries in the matrix. And question 5 compares the simulation versus analytical solution. And from that, we saw that the answers are really, really close. So that's all for today. I'll see you in the next learning session. Thank you so much.